Well, hey there, kiddos. Here is your video over our Quadratics Day 3. It's the third day, so we're going to finish up your book foldable for today. We're going to finish up talking about some special stuff about quadratics, and then tomorrow we'll move on to something called transformations. So here we go. The first thing we're going to talk about is how to tell the difference between something that's linear and something that's quadratic. We've done linear equations before, and if you remember, the form for a linear equation that we used the most often was this y equals mx plus b. And then a quadratic, when we talked about standard form, is y equals ax squared plus bx plus c. So the big difference between these two is that linears just have an x, but quadratics are going to have an x squared. So when you look at the equation, that's what you're looking for. So when you look at number one, obviously it's in this form, mx plus b, because you've got y equals 3x plus 4. It just has an x. There's no x squared. If you were to graph this, it would make a straight line, so it's linear. Number two here has a y equals 5x squared minus 6x plus 3. This time it's got an x squared in it, which means when I graph it, it's going to make a parabola. So this is quadratic. So look at the next two, 3 and 4, and see if you can identify them. So pause for a second, do 3 and 4, and then come back and check your answers. So you should see that 3 is going to be linear because it just has an x. It's not in the mx plus b form. It's written, it's flip-flopped. It's b plus mx, but it's the same thing. There's an x, not an x squared. And number 4 is quadratic because it has an x squared. It doesn't completely match this form, ax squared plus bx plus c, because it doesn't have all three parts, but it does have the x squared, which is important. Now, for the tables, when you are given a table or a data set, you got a couple of options. The biggest one, the thing that you probably want to do is grab a graph, plot your points, and then look and see what it looks like. That's what you should do. Another thing you can do is, we talked about this yesterday when we were looking at tables from our quadratics, and we could see that whenever we had a table of a quadratic, you had numbers that started to repeat, because that's how we found where our vertex was, because it showed where the parabola changed directions, and it always had values that repeated. A linear table won't have that. Also, a linear table will have a constant rate of change because it's linear, and it will have a slope, a constant rate of that happens between all the points. So if we look at this first table, if you look at the y values, it goes 10, 7, 4, 1. So they are all decreasing. You don't have anything that repeats. That doesn't mean it's not quadratic, because sometimes they might give you a table and not show you the repeating values. But we can check and see if this has a constant rate of change first. From 10 to 7, I'm subtracting 3. From 7 to 4, I'm subtracting 3. And from 4 to 1, I'm also subtracting 3. And since my x values all change by 1, that means that my table here has a constant rate of change. It's subtracting 3 every single time, which makes this linear. If I were to plot these points, I'd have a nice pretty line. If you look at number 6, let's look. The first thing we want to look at is look at the numbers here. I got negative 12, negative 2, 4, 6, 4. Oh, if you look right here, this little section, you've got some repeaters. So with this 4 repeats and this 6 repeats after this 6, which probably tells me that this is going to be my vertex. Because I have those repeaters, it probably means we're quadratic, but let's check and see if we've got a constant rate of change just to make ourselves happy. And so from negative 12 to negative 2 is a change of 10. From negative 2 to positive 4 is a change of 6. From 4 to 6 is a change of 2. And from 6 to negative 4, now it goes back to negative 2. And so this does not have a constant rate of change. And you see you've got these repeaters here. And so what that tells me is when I plot these, because these start to repeat, then my parabola is going up. It's getting bigger, and then it turns direction and comes back down. So this one's going to be quadratic. If you aren't sure, grab yourself a piece of graph paper, draw yourself an XY axis, and plot those points. Look at it, see what shape it makes. Number 7 here just gives you a set of data points. And so the first thing I'm going to do is make a table of my X and my Y values so that I can look at them. Negative 3 and 14, negative 1 and 0, negative 2 and 6, 3 and negative 4, 5 and 6. And hopefully you see, those are hard to see. Let me put those in a different color. hopefully you can see that you have some values that repeat. You're getting smaller, you're getting smaller, you're getting smaller, and then all of a sudden you're getting bigger. You've got this 6 and this 6 repeating on either side of this -4. Probably means you're going to have a quadratic, because these are going down, and then all of a sudden it turns direction, and now it's going back up because the numbers start to get bigger. So let's check our rate of change again just to see. So from 14 to 0 is -14. From 0 to 6 is now +6. From 6 to -4, sorry, these didn't go in order. So doing our constant rate of change there doesn't really help us because they don't go in order. So let's flip these real quick. I'm going to put the -2 and then the -1 so that they go in order. Because when you are trying to find your rate of change in your table, you want your numbers to go from least to greatest. And they do. This is a +2. I wrote a negative and I shouldn't have. So this goes -14. This here is +6. From 6 to -4 is +2. Sorry, that's a -6. I apologize. And then from -4 to +6, we've turned back around the other direction, and now we're back at +8. 10. At +10. I'm struggling with my math this morning. But you see, you don't have a constant rate of change. And I also don't have any repeaters. I thought I did, but I didn't because I wrote this wrong. It's a -6 and not a +6. But I don't have a constant rate of change either. So probably what you'd want to do is grab yourself a graph, plot these points, and then look at them so that you can see what's happening. But what I can see is happening is that these numbers are getting smaller and smaller, and then all of a sudden it starts to get bigger, which tells me that somewhere in here this turned around and changed direction. And so this one is also going to be quadratic. It doesn't have a constant rate of change, and those are the only two things we're dealing with, linear and quadratic. And I can see that the numbers were getting smaller, 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 and then all of a sudden they started to get bigger, which means somewhere on that graph the thing started to change direction, which means it's probably going to be quadratic because it went down and then all of a sudden it turned around and started to go back up, making that U shape. So now let's talk about how to write an equation from a quadratic. There's an easy way and a hard way to do this. We're not going to worry about the hard way because we're not going to deal with any of that till you get to Algebra 2. But for now in Algebra 1, we can find the equation of a quadratic if we are given some data, because we can use our calculator to find it. And so the first thing we have to do is we have to know that the data is quadratic. We have to know that what we're dealing with makes a curve, that it's not a straight line. And so that's why we did this part over here. We have to know, is it linear or quadratic, because it changes what we use to find the equation. So if you look at this first one right here, first of all, those points are not pretty. You know, all these fun little decimals. But it does say, find the equation of the parabola. The only thing that makes a parabola is quadratic. So I know my equation, my data is quadratic, so I'm going to use my calculator. We're going to go over here, and we're going to enter those points into our calculator. So we're going to go to Stat and Edit. And if you have any data in your tables, you have to clear it. So remember, you go all the way to the top of the list where it says L1. You hit Clear and then Enter to clear the list. And then in list 1, we're going to put all of the X values, and in list 2, we'll put the Y values. So in list 1, I'm going to do -5, 1, and 2. So you're going to hit -5, Enter, 1, Enter, 2, Enter. Then in list 2, we're going to put our Y values. -43.75. And then 30.65. And then 79.1. And so here are our points, and we want it to give us the equation of the parabola that goes through those points. So instead of graphing it, we can graph it, and no, we can't. We don't have an equation in there. I lied. There is a graph there, but that's because there's something in y equals. We have an equation over here. What we're going to do, let's go back to our table. So we have our points in our table. What we need to do is we need to calculate what the equation is. So we go back to Stat, and then we're going to right arrow over to Calc, and we want to find the quadratic regression this time. When we did this before, we always did a linreg because that's the linear regression. That's what we do when we have a straight line. We don't have a straight line this time, we have a parabola, so we want the quadrag. So you're going to hit number 5, and then you're going to arrow down or hit enter until you get to calculate, and then hit enter and it will give you an equation. And you see it gives you the standard form, ax squared plus bx plus c, and then it tells you what a, b, and c are. All we have to do is plug these in. So a is 5.15, so we have y equals 5.15 x squared. B is 33, so plus 33x, and then c is negative 7.5, so I have minus 7.5. So that is the equation for the parabola that goes through those points right there. So now number 2, we're going to do it again, but number 2 just says find the equation that best represents the data in the table. It doesn't tell us what kind of data it is. It doesn't tell us if it's linear or quadratic, so we have to decide that first. So let's look at our y values really quick. I've got 0, 7, 9, 7, 0. Oh, look, I have this repeating stuff here. I've got 0, 7 and 0, 7, and there's 9 in the middle of them. That tells me that's going to be quadratic because I have these numbers that repeat, that tells me I'm going to have a change in direction. Because they're going up to 7 and then up to 9 and then back down and to 7 and back down to 0. So it goes up and then comes back down. That makes that U shape. So this is definitely quadratic. So we're going to go back to stat and edit. Let's clear our lists again. So go all the way to top, clear and enter. And so then we're just going to enter our values. So 0, 17.5, 32.5, all of those numbers need to go in. So 0, 17.5, 32.5, 47.5, and then the last one is 65. So there's all of our x values, and then our y values will go in list 2. And so we have 0, 7, 9, 7, 0. Those should be easy. 0, 7, 9, 7, 0. So there's our numbers. And again, we're going to go to stat and over to calc, and we still want the quadrag because we know that what we have is a quadratic from looking at the table. So we're going to do 5 and hit enter until we get to calculate. And so here's our equation. Now that is not pretty at all. You have this big ugly decimals. Now we are not going to write down all of those decimals. We are going to go to 3 decimal places and round. So we're going to go 1, 2, 3. Look at the 4th number to decide whether to round up or stay the same. So A is going to be negative 0.008 because this 4 does not round it up. So we're going to start with negative 0.008x squared. Then your B is 551 because this 8 rounds that 0 up to a 1. So I have 0.551. So I have plus 0.551x. And then my C, I'm going to have negative 0.008 because this 7 will round that to an 8. So then I have minus 0.008. That is your equation that matches this table. It's not pretty. Anytime you come across one, so you use your quadratic regression and you get an equation and you've got all these big yucky looking decimals, round to 3 decimal places. So count to 3, look at the 4th one to decide to round or not, and then write down your answer. So that's what we'll do if we get a big yucky decimal. So now let's put this into practice. Let's use some real world problems using some quadratics. So number 1 here, we have a graph that shows the relationship between the height in yards and the horizontal distance in yards of a soccer ball after it gets kicked. So somebody kicked a soccer ball, it went up in the air and came back down. We have to find the following values from this graph. So the first one is f of 7.5. If you will remember, function notation is f of x. So they're telling me that x is 7.5. We want to find out what the y value is there. So on our graph, we have to go to where x is 7.5, which is not really all that pretty. There's 5, here's 10. And so 7.5, it's not very pretty at all, is going to be about right here. It's not quite 10. And so if we go up, it meets the graph right here, and the y value where x is 7.5 is going to be 4. So when x is 7.5, y equals 4. So now we have to do it again. We have to do f of 22.5. So now again, they've told us what f, they've given us the x value. So they're saying x is 22.5. Well, here's 20, 22, 22.5 is going to be sort of in the middle. So we're going to go way up to here and find it on our graph. And if we go over to where the y value is, it's a little bit more than 8. It's not a lot more than 8, but it's a little bit more than 8. And so we're going to call that 8.2. We're estimating it's not perfect, but it's close. Oh. Then the next question they ask us is when f of x equals 2, find the value of x. Remember, f of x is the same thing as y. So they're saying when y equals 2, what is x? So now I go backwards. When y is 2, it meets the graph right here. And if I go down, it's just before 5. And so we're going to say that the value of x is 4. It's not perfect. It's not exact. We had to do some estimating in order to find that. But that's what it's going to equal. And so the next two questions, they ask, number one, what is the maximum height of the ball? Well, this word right here was associated with the vertex when we talked about it yesterday. Well, so the maximum height of the ball is up here at the vertex. If you see, height is on the y-axis, and so at the vertex, y equals 9. And so the maximum height of the ball is 9 yards. So it tells me on the graph and in the words up here that it's measured in yards. Then the next question says, when does the ball touch the ground? Well, when it touches the ground, it's at height of 0. Well, it started on the ground. It landed on the ground way over here. And so it says, when does it touch the ground? Well, we don't have a when because all we have is a distance, but it touches the ground 65 yards later. And so it travels 65 yards, which is really, I guess, what the question is asking is how far did the ball travel? If this had been time, we would have been able to say when, but we're just going to have to say it's 65 yards. That's how far it went. So let's talk about another one. So number 2, during a basketball game, a shot was taken from mid-court and a basket was made. The equation h of t equals negative 13t squared plus 26t plus 5 describes the height in feet of the ball t seconds after it was thrown. All they're saying is this graph goes with this equation. Okay? So now we have to find some things. So the first thing they want us to find is h of 0.5. Well, remember our function is h of t. So they're saying t is 0.5, and if you look at the graph, oh, they even marked it for us this time. They made it so easy. At 0.5, the graph is at 15 feet. At h of 2, it's the same kind of question. Here's 2, go up to the graph. It's at 5 feet. So then the next question, it says, approximately when is the ball 5 feet in the air? Well, we have to look. When is the ball 5 feet in the air? Well, it's there twice. That's where they started. Apparently, that's where they shot it from. But when it's 5 feet in the air, it's also over here at 2. And so approximately when is the ball 5 feet in the air? It's there twice because that's where they shot it from at 0 seconds. But what we're going to say is that after 2 seconds, it's 5 feet in the air. Because this is where it started. That's not really where they're asking for. They're asking when does it get back to the 5 feet. The last question, how high did the ball go? Well, that's going to be the vertex question. So it's up here at the top at the vertex, and you can see it's, if this is in the middle between 15 and 20, well, that's going to be 17.5 is what this is. And it's a little bit more than 17.5, so we're going to call it, it's not quite 18, but I guess we could say it. So it went about 18 feet in the air. It's an approximation. We're not exact because it's not right on the line, but we can be close. So now let's talk about how to evaluate functions. Okay, when we evaluate a function, that just means solve it. That means I'm going to give you a value. I want you to plug it in and find out what it equals. There's a couple ways to do these problems, depending on what you're given. So number 1 here, given the quadratic function and then give you the equation, they want you to find the dependent variables when the independent variables are these numbers. Well, remember, dependent is the y values, independent is the x. So they're saying x are these numbers. Well, when they give you the x values, this is when you use your calculator. So we're going to grab our calculator. We're going to go to y equals, and we're going to type in the function they gave us, this 3x squared plus 2x minus 5. So we're going to do 3x squared plus 2x minus 5. And we're going to just go look at the table and pull the values out. So we're going to go to second and graph. And the first x value they give us is -3. So in my table right here, when x is -3, y is 16. So the first independent value that I have, or dependent value, is going to be 16. The next value they want to know is when x is 0. So when x is 0, y is -5. Then when x is 1, y is 0. And when x is 5, y is 80. So there are your values. If they give you the x values, to go find the y values, plug it into your calculator and just go look at the table. Okay, as long as the x values are whole numbers. If they're not whole numbers, you'll have to do it like we're going to do number 2. Because number 2 is a little bit different. Number 2 says, given the quadratic function, find the independent variables, which are x, when the dependent variables are these numbers. Well, now they've given you y, and they want you to find x. So we're going to try this with our calculator and see if we can do it. We're going to go enter this function in. So we're going to go back here. We're going to go back to y equals. And we're going to enter in our function, which starts with -5x squared. Whoops, I forgot my 5. How did I miss that? 5x squared. And then the rest of it is plus 2x plus 6. So then I have plus 2x plus 6. And we're going to go look at the table again, but this time we want to look at y values. I'm trying to look at the y values that they gave me, and the first y value I have is -82. So I'm going to look over here in my y values, and I see right here it's -82. And so the y value is -82, the x value is -4. So the first value I'm going to have in my set is -4. Then the next y value they give me is 6. So I look through here, well here y is 6, that's when x is 0. Then they gave me -109, which is right here when x is 5. And then the next value is -577, and I'm going to have to scroll in my table until I see that show up in the y column. There it is, right here. Y is -577 when x is 11. So the last value is 11. And so your calculator is probably your best bet for this kind of problem. It's not the only way to solve it. You can plug in the values and then solve, but the calculator is the best way to do it. So number 3, given the quadratic equation f of x equals this, we want to find these values. Well, we're going to go back to our calculator, and we're going to do this again. So we're going to go back in here, and we're going to go back to y equals, and we're going to enter in our function, which is 2x squared minus 3x plus 1. We're going to go back to the table, and there's a couple of ways to do this. Okay, they have given you your values. These are your x values. We want to find the y values, and the first one is -32. There are a couple of ways to do this. The easiest way, we're going to scroll until we get to -32. It might take a couple of seconds, but it's okay. Your calculator probably goes faster than mine too, but so here we are. When x is -32, the y value is 2,145. So I'm going to plug that in, 2,145. Now, if you don't want to do this and you don't want to use the table, you can plug this in. You can do 2 times -32 squared minus 3 times -32 plus 1. All I did was plug this -32 into my x's, and you can type this in on your home screen. So from here, you can do 2 times -32 squared minus 3 times -32 plus 1. And you can just hit enter, and your calculator will give you the number, which you see is 2,145. It's the same number we got from the table. It doesn't matter how you choose to do it. The table's just usually the easiest. The next one, they say f of 1. We want to know where x equals 1. Well, I've done all this scrolling through my table, and I don't want to really scroll again. So we're going to reset our table to go back and start at 1. So here's how you do that. If you press second and then window, it'll give you your table setup menu. And right here, is the number that we want our table to start at. Well, right now it's starting at negative 32 because that's where I scrolled to. I don't want it to start at negative 32. I want it to start at 1. So I'm going to type in the number 1. Then I'm going to go to second graph. You'll see my table now started at 1. When x is 1, y is 0. The next one is 3. When x is 3, y is 10. The next one is 44. You've got two choices. You can scroll until you get to 44, or you can go back to second window and tell your table, oh, I want to start at 44. So tell it we want it to start at 44, go back to second graph, and now it starts at 44, and when x is 44, it's 3,741. So you can either use the table, or you can plug these values in for x and then use your calculator to do the calculation part, and it will tell you what it equals. Those are your options. I feel like the calculator is probably the easiest, and so that's probably what you'll want to do. So when you come to class tomorrow, this is what we'll practice. Have a good rest of your evening. I will see you then.